Okay, I've been having a bit of Saturday night fun as a kid, teenager, you know. Nothing I loved more than hanging out with my mates, but nothing I loved more than that was hanging out on my own, doing the stuff. And I don't know, for some reason it just makes me happy. You don't have to deal with politics, moods, different personalities, nothing. All you got to deal with is electric shocks, and you know how to not get them, so it's all good. Okay, so this is pretty different going on here. Got a taser going through a spark gap. Give you a little looky here. And then it's going into a dual bifilar like this one here. No, sorry, it's a single bifilar. God, I've got to say this right. This is a lazy man bifilar. So you got your 10 gauge, 14 gauge wire. It might be 16, but I think it's 14 gauge. And I've got another one underneath. Okay. And they're wound around about the same. This one on top's about 2 winds more. So I've tested it with the inductance meter. It's different. I can, when you wind them big like this, they go up and down. You can see the depth there goes up and down, gets caught in the figure 8. So what happens also is when you're winding, they can get different tightnesses, and you might look the same using the same wire, but it's actually a lot looser, and therefore you've done more winds or less winds. So it actually is quite hard. There is a way to do it. Do it between some perspex. It gets harder as it gets bigger, that's the issue, and that'll keep it on an equal plane. But moving on, so the output of the primary underneath is getting induced into this bifilar on top. The output of that bifilar on top, there's no reason for this, I just was playing around, so I just kept on building up. I've done a quarter wave resonance on this toroid, so it's 70 turns, and I think I got 17.5 turns on the primary. Coming out of, so you get your primary there, secondary there, I guess you'd call it the primary of the toroid, and then the output secondary of the toroid is 70 turns. So that makes it quarter wave. I'm not doing it for any reason, I'm just playing around. But I did put the fluorescent tube there. It tends to light best in the middle, so it's the electromagnetic waves are strongest. I put the toroid on, it lit up even more, and then I put an earth ground on the points there, on both points, and it lit up even more. The output of the toroid, of the 70 turns, goes into this 30 kV diode, 100 milliamps, and lights up this light. Now, so far for the power draw, I haven't seen anything different. I've only added to the system, which you would think would make it less efficient. I'm getting more power usage and getting this to not light up very bright. But I haven't seen anything. I'm playing around with the earth ground. At this point, I haven't seen anything do anything. I mean, I can't really see why it would do anything. This is around about 1-to-1 coupling, so you're going to anything other. You're going to get a loss if anything. I've played around with this 30 kV capacitor, and I think I got I think that's about 2000 kV capacitor there. When I put it across, like either capacitor, when I put it across the load before the diode, there we are. So we've got these wires here, I just whack it over there. I won't do it because it's just no big deal, but it takes obviously it out of resonance, as I did the same before with the output of the secondary here. I had it going straight into the light, not going into the toroid, and the same thing, I was putting it on, creates an LC resonance, and yeah, just took it straight out of resonance. So that's the resonating coil underneath. Okay, that resonance is based on that spark gap. So either you create a coil that's way out of the same octave, like a small coil or a far larger coil, or just completely out of any multiplications of, let's say, third, quarter wave, things like that, and it'll just be out of resonance, and your coil, this will heat up and you'll see a draw on your meter. So it's the same thing, putting a capacitor there, and inductor and a capacitor makes an LC circuit, so it resonates on its own, and it just goes into a dwell. I think it's called dwell, where, well, it's out of resonance for starters, but then it just sort of like bogs down, and yeah, the whole system just goes down under load, and it's just not running in any way efficient. So basically what happens is, my point is the same thing, which this is 3 steps down. So this is a primary underneath here, a secondary going into the primary of this, and then a secondary out. So 4 steps to get to here. So when I whack that capacitor over that there, and it takes the whole system down, this spark here changes frequency. So you can actually see the frequency here and see the frequency change. I'll quickly do it with the light on. It makes it a bit hard with the light on, because you can't, well, you won't see that really glowing. You'll see that glowing, but anyway, we'll do it. Okay, so when I just go over here, right, now look at the spark, right? All the energy is going in there, it can't go past there. So I thought that was rather interesting from the perspective. It was predictable, of course. You know, didn't really think about it beforehand in ways that you could see it, but that's actually turned out a way where you can actually really see it, that it's under load, it's not flowing easily, it's actually that spot there it becomes the resistance point. It can't go in there and do what it wants to do, because everything past that system is just bogging it down. I've never really seen it, or it hasn't occurred to me that it can be visual in a spark gap, but the point being, a spark gap, you can visually see things if they go out of resonance. Obviously, if you've got other light emitting things like this globe and this globe, you can also see it. We'll do it again with this globe. You can see that go down, and if you look closely at this neon, bang, there you go. So an interesting little setup to display and illustrate what happens to a spark gap if it's taken out of resonance. It just gets hot, and I guess the frequency, I haven't measured it yet, but I guess the frequency is, let's try that again and see if we can tell by audible. Yeah, I'd say that frequency's going up. I'd say that frequency's going up, but a lot of more energy is going into that. You can see that it actually glows. So I can only run this about 3 or 4 minutes at a time, and it just starts to get warm. If you do that with your taser and give it time to cool, it'll last a long time. Even if you run it, you know, quite high, like that's at 3.44 volts. If you run it at 7 volts, you can just run it nowhere near as long, but there's no need for me to do that. The spark gap is just what's really, I can go up and down in voltage on this. I'll let that cool down. I'll do that next video. I can go down, up and down. I can adjust it on the fly, and you can actually see the whole system become more efficient, because you can see that the glow in that become a bit greater, and the glow in that fluorescent. So I'll do that for the next video. Stay tuned. I'm going to go and make a cup of tea, and I'll see you on the flip side.